In this video, we are going to be reviewing for Quiz 4. I have given you some problems on a review, and I would like you to work through each of those and then check your answers with the problems that I've worked through on this review. Alright, so if you have done each of the questions, then go ahead and play the rest of this video and let's go over the answers to each of the questions. Alright, let's go ahead and begin question number 1. For question number 1, it says find all vertical asymptotes of the rational function, and it gives you the rational function. Now, in looking at this function here, notice the denominator here. It's x squared minus a 4. In order to find the vertical asymptotes, I have to determine what would cause the function to become undefined, because that is where my vertical asymptotes will be found. So, in order to find that here, we are going to set my denominator, x squared minus 49. We're going to set it equal to 0. Then I'm going to factor it. Now, we could also extract the root. Either way is fine. I'm going to factor it and then use my zero product property and set each factor equal to a 0. And then I'm going to solve for x in both cases, and I will get x is equal to a 7, and I will get x is equal to a negative 7. That means my vertical asymptotes are going to be at x equals 7 and x equals negative 7. In question number 2, it says find the horizontal asymptotes of the rational function and gives you the rational function. Now, in looking at the rational function, you need to pay attention right here to this not being in descending order. So let's first of all take that and let's put that in descending order. So on the top I have negative 600 x to the third plus a 400x minus 7200 over top of, and I have a negative 300 x to the third minus 3000. Alright, and of course that is equal to f of x. Now, I am going to just pay attention to this piece of it right here. Okay? Now, noticing here, I have an x to the third and an x to the third. When they are the same, that means what I'm going to do is I'm going to find the ratio of these coefficients right here, and that is going to be my horizontal asymptote. So, my horizontal asymptote will be y is equal to 2. For question number 3, it says determine the intercepts, vertical and horizontal asymptotes, and sketch the graph of the rational function. Be sure to draw any asymptotes using dashed lines and label all asymptotes and intercepts. Alright, so let's go ahead and begin this question here, and I'm going to kind of step this out just a little bit here. So we're going to start with step number 1, and step number 1 is to find the intercepts. We can start by finding the x-intercept. In order to find the x-intercept, we're going to take my numerator, so x squared, and we're going to set that equal to 0 and solve. And of course, x squared equals 0, therefore x equals 0. So that is our x-intercept. Next, we're going to find our y-intercept. To find the y-intercept, you plug 0 in for x. So you're going to plug 0 in every place you see an x. So you're going to plug 0 here, here, and there. And of course, we're going to get 0 over 4. So that means that our y-intercept is going to be y equals 0 as well. Okay, step number 2 is to find the asymptotes. In order to find the vertical asymptote, again, we're going to set our denominator, x squared minus a 4x plus a 4 equals to 0, and solve. Factoring that, that gives us x minus 2, and x minus a 2 equals a 0. And when we set that equal to 0 and we solve, we get x is equal to a 2, and there is our vertical asymptote. Now, in order to find the horizontal asymptote, you're going to look at the degree in the numerator, the degree in the denominator. They are the same, so it's going to be the ratio of the coefficients. So my horizontal asymptote will simply be y equals 1. Okay, next we're going to sketch this out. So let's start by drawing our axes, labeling things off. All right, I'm going to use red here, and I'm going to put x equals 0. So there it looks right there. There's my x-intercept, and there's my y-intercept. It's right on the same point here. And then I'm going to put my x equals 2, my vertical asymptote, running right through there. And I'm going to label that x equals 2. For my horizontal asymptote, it's going to go through y equals 1. So it's going to go right through there. And let's label that y equals 1. Next, I'm going to take my graphing calculator, and I'm going to test to see just where it is in which region. I want to know where it is, over in this region and where it is over in this region. All right, so let's go ahead and graph it, and then we can determine just where the graph exists. All right, so after you've taken a moment to sketch this out, here is where the graph is. Okay, so first of all, it is asymptotic to x equals 2, but what it does is it crosses the horizontal asymptote, bounces off the axis at x equals 0, and then because it comes asymptotic to y equals 1. And of course, on the other side, it is asymptotic to y equals 1, and then becomes asymptotic to x equals 2. So kind of a weird graph, but that's what it looks like. In question number 4, it says find the inverse of the function below. Okay, so we're going to take a look at this relation right here and just identify the inverse. Now the inverse, all you're going to do is switch the x and the y coordinate point. So we're going to do it here, 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 and there. In looking at each of these, you're looking for these 2 points. Well, I see it there. Looks like I see it there. Yep, I see it there, I see it there, and I see it there. Okay, so it appears to me that the answer to number 4 is going to be A. In question number 5, it says use composition of function to determine whether f function and the g function are inverses of one another, and then use an argument of the definition to justify our answer. All right, so in looking at this question, let's determine, is f of g of x equal to x? Well, let's see if it is. So I'm going to take a, we're going to substitute the other function in here, so 1/8 x minus 9 over 8 plus 9, distribute in my 8, and I will end up with x minus 9 plus 9, which equals just x. So you've shown that f of g of x does equal x. Now let's go a step further, and we're going to see if g of f of x also equals x. So that means I'm going to take the second function and I'm going to plug the first function in there. See if I can squeeze this in with enough room here. All right, now we're going to distribute that in there, and I will end up with x plus 9 over 8 minus 9 over 8, which is x. So here's what I've shown. I've shown that f of g of x equals x, and I've shown that g of f of x equals x. So now for our argument. For our argument, you're going to say, since f of g of x is equal to g of f of x equals x, then they are inverse functions. And that's it. In question number 6, it says, sketch the graph of the function f of x equals 1/2 to the x. Be sure to show the asymptotes using a dashed line and label any asymptotes and intercepts. All right, so in doing this question here, we're going to start with drawing ourselves an xy coordinate, and I'm going to label it off. All right, now, first of all, looking at this function, let's just kind of look at what's happening here. I see that this value is a 1/2. That means this function is going to be a decreasing function. Notice that it doesn't have any h and it doesn't have any k. And the a value, it doesn't have an a value out there to affect it either. All right, so let's go ahead and just graph this function. So I know that this function is not going to be translated right or left or up or down. It's going to cross at this point 0, 1, so let's go ahead and label that. I know that it's going to have an asymptote right on the x-axis, so I'm going to put my dashed line asymptote running right there. And then my graph is going to just come down here. It's going to go through that 0, 1. It's going to become asymptotic to the x-axis. And that is all of the graph of this. Now let's do one more thing. Let me go ahead and label this. That's going to be at y equals a 0. And now the graph of this function looks really good. And for our last question, it says, a cup of coffee is heated to 160 degrees Fahrenheit and placed in a room that maintains a temperature of 50 degrees Fahrenheit. Now, it says the temperature of the coffee after t minutes is given by t of t. Now, that means temperature after time t, and that is equal to 50 plus 110 times e raised to the negative 0.033 t. Find the temperature to the nearest degree of the coffee 45 minutes after it is placed in the room. Now, all you really have to do in this problem, something very simple here, is you just need to find what t of 45 is going to be. So you're going to plug that in, 50 plus 110 times e raised to the negative 0.033 times 45. Now you're going to take your calculator, you're going to enter that in, you're going to crunch through it, and when you crunch through this problem, you're going to get t of 45 is equal to 74.915257, and it keeps going on and on and on. However, it says right here, round it to the nearest degree. So to the nearest degree is going to be 75 degrees. So in a sentence, you're going to say, after 45 minutes, the coffee will be at a temperature of 75 degrees Fahrenheit. All right, guys, well, that wraps it up for this video key. Study hard for this quiz, and I will see you in class.